Okay guys, in this video lesson we're going to talk a little bit more about an application or a couple different applications for the electrochemistry we've been studying. Alright, the first one are batteries. Alright, in our society it's pretty obvious that we are very heavily dependent on mobile technology and the ability to get electricity or electronics working away from a cord. Okay, to do that we need to be able to store energy, and that's where batteries come in for us. They're actually able to store energy for us to then to be used. Now, what a battery really is, it's actually just a group of voltaic cells hooked together. Okay, so if you actually pair up a bunch of cells together, you can change the voltage of what you're getting, and you actually can create a battery of cells. Okay, thus the term a battery. All right. For example, down here, if you look closely, there's kind of there's kind of a round object, another round object, another round object, another round object in here. This is actually 1, 2, 3, 4 cells put together to create a battery that's 9.6 volts. Okay, to figure out how much voltage each one of these cells were, you would take the 9.6 divided by 4, and that would tell you how many volts each single one of those cells actually would be able to provide for you. Okay. A car battery looks like this actually has a grouping of 1, 2, 3, 4, 5, 6 different cells in it that creates a car battery. When you get a flashlight or in a device and you put the standard alkaline batteries in, you hook them together, and you usually put more than one battery into something. So think about like your calculator, for example. You put in 4 AAAs in there. Now, technically, each one of these is actually a single cell. We still call it a battery, but technically those are all individual cells that we hook together to run our devices. You put 2 or 3 or 4, whatever you need to, inside there, and that creates the battery of cells to run our device. Okay, so these are all different types of batteries. So what we're going to do is go over 3 very common types of batteries that we use in our everyday lives. Okay, each one's a little different, and we're not going to spend a ton of time on each one. I'm not going to make you memorize all the little different details of it. What I want you to get from this is kind of a perspective of how every battery works the same, but at the same time has their own unique properties to it that gives it what makes it unique for us. Now, the first one is a lead acid battery. All right, a lead acid battery is very important to us because most, if not all, cars that run off of gasoline use a lead acid battery to start the car. Okay, its sole purpose in life is to be able to dump a ton of energy very, very quickly into a starter to turn an engine over. Okay, so it stores energy for long periods of time and then it is able to dump it really fast. Now, to do that, if you notice, there's 1, 2, 3, 4, 5, 6 cells. Okay, each cell provides about 2 volts, and then we get a 12-volt battery from that. Okay, so when you talk about batteries for like your car, we talk about getting a 12-volt. This is why, because each cell provides 2 volts. Inside those cells, you actually have your cathode and your anodes. And believe it or not, inside a single cell, there's actually multiple layers of cathode and anode put together to generate the right amount of amps, or the right amount of current flow that we need. Okay, what a lead acid battery has is at your cathode, you have a lead oxide type of material. At your anode, you have a lead type of material. So the transfer of oxygen back and forth is what actually causes this to happen. Okay. Now, the reason why they call it a lead acid battery is obviously the lead part is what your plates are made of, but the solution that sits in this is actually a sulfuric acid electrolyte. Okay. Now, sulfuric acid is one of our strong acids, and sulfuric acid is actually one of our more dangerous acids that we have. That's why lead acid batteries, they tend to seal them up really well. Modern lead acid batteries, usually you can't open them up, you can't get inside them for our modern cars. However, lead acid batteries for like lawnmowers and like other smaller devices, those kind of things, they actually have ports where you can refill the electrolyte if you need to. So you can, buy the proper sulfuric acid to refill them and maintain them. Okay, so kind of key pieces here is realizing that you again have 6 cells that gives you your 12 volts. It's the plates are a combination of lead and lead oxide, and the electrolyte here that we're using is sulfuric acid. Okay, this sulfuric acid is really strong and it's very concentrated. So you need to be very careful around a lead acid battery, because if it breaks or if it leaks or if it freezes in the middle of winter, that can become a very dangerous situation because the acid in here can create very significant chemical burns on people. That's why in car accidents, if the battery is disrupted or if the battery is actually damaged, that's one thing that fire and ambulance people are very, very aware of, is the fact that this could be a potentially chemical burn scenario if acid was somehow got on people who were part of that accident and those kind of things. Okay, guys, so that's our lead acid battery. It's used for cars, lawnmowers, that kind of stuff, to get them to start, basically. The next kind of battery that we use are our alkaline batteries. Okay, these are our disposable batteries. These are the batteries that you throw in your calculator and it runs forever, or they're in those little miniature flashlights maybe you had as a kid, or are in our smoke detectors in our house, those kind of things. These are batteries that are designed to run until they run out of power, and then you dispose of them by recycling them. You should never throw a battery away because of the materials inside them. You should always bring them back to a store and recycle them. All types of batteries, really, you should. Alkaline batteries are actually made up of a single cell, and there's lots of little layers to them. Okay, you have an outer side casing that's basically there just to to give a label for the company. Then you have a stainless steel can, they call it, or a shell that actually provides a place for electricity to flow. So this outside layer is non-conductive, so it does provide kind of a service. And then you have your cathode. Okay, so the cathode is wrapped around the outside, and then you have a separator. Okay, that separator keeps the cathode and anode apart from each other, just like we have basically two different cells for a voltaic cell. It also kind of acts as a little bit of a salt bridge, allowing a little bit of charge balancing here. Then you have your anode, and then you have your bottom, and you have this electrode that slides up inside that anode. So what happens is you actually get current to flow from here around the cap into here, and that's how that kind of flows. Okay, so these batteries are made up of multiple layers. One layer is a cathode, one layer is an anode, and depending on the company and depending on the type of battery you buy, there is a variety of different things that make up the cathode. Manganese dioxide is a common one. Carbon is used often. The anode is some sort of like zinc powder or electrolyte, those kind of things. Again, I'm not real concerned that you know exactly what's inside them, but just kind of realizing that how they actually go about building these things is kind of important to us. These are disposable. We cannot recharge these things, okay? So they're a one-way street. Once they burn out, we recycle them. That's how these kind of guys work. Now, the lithium ion battery is probably the one that you guys are most familiar with. Okay, this is the one that is in the majority of high-end electronics that we recharge. Okay, there are other types of batteries that get recharged, like metal hydride batteries and nickel metal hydride batteries. But the newest technology is the stuff that we find the most of right now, especially in all of our cell phones, is lithium ion batteries. Okay, what's nice about lithium ion batteries is that they're able to actually discharge, and then we can plug them in and we can recharge them up. So we can basically reset them. Okay. If you take a look at how that kind of works, when you are discharging, what you're doing is on our anode side, we're letting electrons flow this way over this side. As the electrons flow from this side to this side, the electrons are coming over here. The lithium ions that are over here that get generated from the electrons leaving. So you have lithium metal, and then they ionize, so the electrons leave. So then this lithium ion that gets created, it actually slides through the separator, kind of acting as a salt bridge, and it slides over to this side. So as the electrons flow this way, the positive ion flows the other direction. And then these electrons then attach to these positive ions. So it's almost like they're trading places. So like, hey, I'm going to give my electrons up here. They're going to go through the wire. While they're running this way, I'm going to slide through and come over here instead. Then the electrons come back down with less potential energy because they've lost their energy to your device, and then they reattach and make lithium over here. Well, to charge it, you just reverse it. So instead of them running in their spontaneous direction this way, you put a power to it or a voltage to it, which then forces them to run in their non-spontaneous direction. So now you force the non-spontaneous reaction. You force the lithium ions to go up, over, and you force the electrons to come down. Sorry, you force the electrons to go in the opposite direction, which then the lithium is moving in this direction instead. So it's just kind of a balancing act, back and forth, back and forth, back and forth. Okay, that's the beauty of a lithium-ion battery, is that you can go either direction pretty easily, and we basically, allow the spontaneous reaction to run until it dies, until you run out of ions on this side, and then you can run the non-spontaneous by putting a current to it in the opposite direction, okay? But by basically applying the shot-of-the-H principle of forcing the reaction to run in a different direction, okay? So that's your lithium-ion battery. Now, obviously, you know, different batteries have different amounts of cells here that make it run, different voltages and all those kind of things. But that's kind of your basics behind what a lithium-ion battery does, okay? We're actually going to stop the video lesson here, and then we're going to go on to our next thing about corrosion in our separate video lesson. Thank you.